So when we talk about acids and bases, let's quickly look at some of the definitions. How do people define acids and bases? There's this one definition, it's called the Bronsted-Lowry Definition, which says that an acid is actually a proton donor, and a base is a proton acceptor. Now, when we talk about protons here, we are actually talking about hydrogen. So hydrogen on the periodic table in its ground state has one electron and one proton. If you look at hydrogen, the atomic number 1, the mass number 1, which means that in its nucleus it only has a proton. And we know that it carries an energy level for one single electron. So what does hydrogen like to do? It likes to get rid of this electron, and therefore what we are left with is simply this, which is actually a proton. So when we talk about a proton donor, we're talking about something that donates H+. And when we talk about a proton acceptor, we're talking about something that accepts H+. So we're not talking about protons moving around in the nucleus. We are talking about the hydrogen ion. The Bronsted-Lowry definition we've looked at. There's another definition here that we just need to touch on. It's called the Arrhenius definition. For an acid, the Arrhenius definition is that there is an increase in the concentration of H+, and for a base, there will be an increased concentration of OH-. So these two definitions are also important just because they are a little bit different to the Bronsted-Lowry definition. Now, when we look at grade 9 work, which for most of us is a bit of a blur, we know that if you take an acid and you add a base, they can neutralize each other. And the product that forms will be salt plus water. Now, the water is actually H plus and OH minus that is combined. So when we look at the Arrhenius definition of an acid and a base, we can easily see where the H plus comes from and where the OH minus comes from to combine to form the water. Now, when we look at the properties of bases and acids, they are different in their taste, but they neutralize one another. The most common acids and bases, you need to know the names of them, you need to know the chemical formulae. So, for example, an example here of a strong acid that we use is HCl, and an example of a base NaOH. And I'm going to use these two also to explain it in a little bit more detail. If you have an acid like HCl and you add a base like NaOH, the product that will form is very interesting here because we know that NaOH is actually an ionic compound. We know that because Na is a metal and OH minus non-metal. So because it's ionic, what we are actually looking at here is Na plus and OH minus attracted to each other. So when we look at the acid-base reaction, what we see is that the HCl and the OH minus will actually react here. So we know HCl and NaOH forms salt. Now a salt here is coincidentally table salt, but a salt is actually any ionic compound that forms, and we know H2O is the other product. But when we look at the definition, the Bronsted-Lowry definition of acids and bases, what really happens here? This H is going to be donated from hydrochloric acid to OH minus. And one of our products that forms therefore is H2O. What stays behind is the Cl minus that will attach to the Na plus, and we actually then normally write it as NaCl and without the charges because we know that that means an ionic bond is formed. So this is a basic acid-base reaction. Now I'm quickly going to talk about strong acids and strong bases. A strong acid, for example, let's take HCl. When we add water to it, a strong acid will ionize almost completely, which means that the ions that form here will be H plus and Cl minus. We say it ionizes because covalent molecules are not ions. So it goes through the process of ionization. A strong acid ionizes almost completely. A weak acid, like for example, let's take carbonic acid, when we add water to it, most of it stays as H2CO3, and a very small percentage will form ions. So we know that the concentration of the hydrogen is much lower for this weak acid. When we look at strong bases, now remember bases are normally ionic compounds. So let's take a strong base like, for example, NaOH. It is already ionic, so it is not going to go through the process of ionization. It will simply dissociate. So what we will get in solution is Na plus and OH minus. Now we add the water above the arrow. If you struggle with this, go and have a look at the video, Reactions in Aqueous Solutions, that explains the difference between where we add the water when we have ionic compounds and where we have covalent molecules. So a strong acid ionizes completely, a strong base dissociates almost completely. You see, it has nothing to do with anything other than how many ions it actually forms in solution. When we look at the strength of acids and bases, it has nothing to do with the concentration. You know, when Oros is not tasty enough, we add more of the concentrate, and it's stronger. So we tend to think that strength has something to do with concentration. But an acid will still be a strong acid regardless of its concentration. So I'm going to use HCl again. If you have a 1 mole per cubic decimeter concentration of HCl, you have a strong concentration of a strong acid. But let's now add like 100 liters of water, and we really dissolve the HCl in that, and now we see our concentration is going to become much less. This simply means that we have a dilute or a weak concentration of a strong acid. So an acid or base doesn't become strong or weak based on concentration. You can have a very concentrated acid that is a weak acid. You can have a very dilute acid that is still a strong acid. Why? Because strength depends on how many ions will form when we add it to water. That's the only thing that determines its strength. Now I'm going to show you an example of an acid-base reaction. It's also called a proteolytic reaction, which makes sense because protons are the things that move here. And just keep your eyes on the screen for this one. If I take HCl and I add NH3, HCl is my strong acid here, NH3 is a weak base. So have a look at what happens here. The HCl is going to donate the hydrogen, which means that we see that NH4 plus will be one of our products. And then we also see that the Cl minus that is left is then going to be available on this side. The HCl becomes Cl minus and the NH3 becomes NH4 plus. So HCl donated the proton, so this is my acid, and NH3 accepted a proton, this is my base. But as you can see, these products that form are dependent on the acid and the base that we use. So this acid is going to actually form a base that we call conjugate base. And this base is going to form a conjugate acid. So I want you to think about conjugate as like they rely on each other. If this one is an acid and it releases a hydrogen, it forms a conjugate base. This base accepts a hydrogen, it forms a conjugate acid. So let's just look at one more example. If I have HNO3, which is nitric acid, and I add water, one of my products will be this hydrogen is going to be donated to the H2O, which means it forms H3O plus. And then I am left with NO3 minus. So if we go and look at this reaction, we see HNO3 becomes NO3 minus and H2O becomes H3O plus. So HNO3 is my acid and NO3 minus is my conjugate base. Here H2O is my base, because it accepts a hydrogen from HNO3, and H3O plus is my conjugate acid. You need to be able to identify conjugate acid and base pairs for your tests and exams. Here's a little shortcut. If you have a substance like this, and you know it's an acid, they ask you for the conjugate base, it will be this substance minus a hydrogen. Instead of NaOH, let's use OH minus. They want you to give the conjugate acid. What you do is you simply add a hydrogen, and it will be H2O. So a conjugate acid and a conjugate base, you just need to focus on whether hydrogen is added or hydrogen is being released. If hydrogen was released from the original substance, a base will form. If hydrogen was accepted, an acid will form.
Can an acid donate two hydrogens?
Yes. If you look at, I'm going to use HSO4 minus. Okay. If you have HSO4 minus, if it accepts a hydrogen, it becomes H2SO4, which means that this one is my base and this is my conjugate acid. If it loses a hydrogen and forms SO4 2 minus, we know that this was my acid and this is my conjugate base. But it is possible to lose more than one hydrogen, especially with sulfuric acid and phosphoric acid.